Okay, so this will be part 2 of the video, and I'm going to give you one more example of the arrow notation style problem. So let's do this one. G, oops, try that again. G of x is paired with, let's do x squared plus 2 over x minus 3. And I'm going to give you a domain, and the domain includes 2, 4, and 5. Okay, and we're going to find the range. Again, it might make you feel better to change the arrow notation to your standard x and y equation. So y equals x squared plus 2 over x minus 3, if that makes you feel better. What we can also do is set up a little chart here. So x, that's where we're going to put the domains. And then we have our x squared plus 2 over x minus 3. That's what we're going to do with the x values. And then we're going to come out with our y. Okay? So let's see how this works. Remember, our x values were 2, 4, and 5. So I'll just write those in right here. 2. And leave myself some space because I'm dealing with a fraction now. So 2, 4, and 5. And let's just plug it in. So we're going to have 2 squared plus 2 over 2 minus 3. So I'm plugging in using the red pen just to see where the domain number is going. And now, again, we can probably do this mentally. So 2 squared, that would be 4, plus 2. So we have 6 on top, and 2 minus 3 is negative 1. So 6 over negative 1, or just negative 6 we have. Now let's plug in 4. So I'm going to actually just make it more obvious here. Okay. So let's plug in 4. So we're going to have 4 squared, and we're also going to have a 4 down here. So that is squared plus 2, and that is minus 3. And again, we can try that mentally. So 4 squared would be 16 plus 2, so we have 18 on top. And then we have a 1 on the bottom, so 18. And now we're going to plug in 5. Oops, that was a 4. And that 5 is squared. We're adding 2. Okay, so again, mentally on top, we have 25. 5 squared is 25 plus 2. We have 27, and on the bottom we have 2. And so we can just leave that as is, or if you want to make that 13.5, that's okay too. So we answer the question like this. That's just our work. The way we answer it is we say R for range, and we just give all the values. I usually like to go low to high, or you could just keep it in the same order that you had it in. So negative 6, 18, and 27 over 2. All right. Now I'm going to move on to a different function notation, which I like better than arrow notation. And I'll explain why in a minute, but you'll find that it's quite similar. So, let's see. If you were given one that looks like this, f of x equals, let's say, 3x minus 1. Let's put kind of an easy one up there. So the way you read that, it's actually in the book, and it has a couple different ways of saying it. It's just above example 1 there on page 379. You would read this as f of x equals 3x minus 1, and you might think of it as the value of f at x is 3x minus 1, which kind of makes more sense if you graph it. And so I'll graph it after we work on this, just to show you why that wording makes sense. Okay. Again, it looks funky. You've got the f, you've got the parentheses and the x. Normally that means that you're going to multiply f and x. That is not what you're doing in this case. Essentially this means y equals 3x minus 1, just like the arrow notation meant that. Okay, so remember, do not multiply the f and the x. So you'll be given a domain for something like this. So you might get a domain of, and again this is given, maybe -1, 0, and 1. Okay, and we're going to find the range. Okay, we're going to find the range. So you might set up a chart. You're going to want the x values. Here's what we're going to do to the x values, and then you're going to get the y values, or the range. Okay, so we're going to use for the range, or for the domain, sorry, -1, 0, and 1. And it might be helpful to write domain and range up here. That makes more sense. And we're just going to plug in all these values. Let's do it like this, so I can stop switching my pens around for a moment. And so -1 gets plugged in here, 0, and 1. And again, mentally, we can just do this. 3 times -1 is -3, minus 1 is -4, 0 minus 1, and 3 minus 1. And so the answer, very similar to the last one, would be R, or range, equals -4, -1, and 2. And that is it. All right, let's take a look. If we can graph this, let's go 2 pages here, on 2 sides. All right, let's go to my content, pictures. Okay, so I'm going to graph this. Let's make that a little bigger. All right, there we go. So, using slope-intercept graphing, I can start my graph at, again, so we're graphing y equals 3x minus, whoops, anyway, let's try, okay, let's try that again. Y equals 3x minus 1, which should be the same as f of x equals 3x minus 1. Using slope-intercept graphing, you can start at -1 here. Oops, not that. There we go. And then we can do a slope of 3. So up 1, 2, 3 over 1. Or alternatively, we could go down 1, 2, 3 and left 1. So up and right, or down and left. And you can just keep doing that to give yourself a good look at the line. Okay. So, okay. It's kind of freehand, it's not perfect, but it'll do. So if you look at the graph, and I go back to the function notation, the f of x, and we say the value of f, okay, or the value of y at x is 3x minus 1. So the value of y at 1, for instance, if we look right here, the value of y at 1 is 2. because 3 times 1 minus 1 is 2. So the value of y at 1 is 2, 1 comma 2. Or the value of y at negative 2 is, what, 4, 5, 6, negative 7. Okay? So that's kind of how that function notation works. The benefit of it, oh darn it, running out of time.